Hey everyone, welcome to I4 Math, your ultimate guide to acing CBSE Class 12 Mathematics. Whether you are preparing for your board exams or just brushing up on your concepts, I'm here to make your learning journey smooth and fun. Today we are tackling one of the most intriguing topics from Chapter 11, three-dimensional geometry, finding the distance between two parallel lines and skew lines. These problems often appear in exams and are worth solid marks if you know the right techniques. But wait, it is not just about formulas in this video. I will share some insider tips and shortcuts to help you solve these problems faster and more accurately. By the end of this session, you will feel confident enough to solve any 3D geometry question thrown your way. If you're new here, don't forget to hit that subscribe button and join in our growing community of Max champions at i4 Math or in my WhatsApp channel 8778393314. We aim to make Max exciting and help you score full marks in CBSE exams. Ready to dive into 3D geometry? Grab your notebook, stay focused, and let's get started. Find the shortest distance between the lines whose vector equations are given. From the given two lines, we can write a1 vector, b1 vector, a2 vector, and b2 vector. Here, the a1 vector is I cap plus j cap and 0 k cap. Why we are taking 0 k cap? Because here the k component is not given. So whenever it is missing, we can take it as 0 k cap. And then a2 vector is 2 I cap plus j cap minus k cap. So from the second line we can write this a2 vector, and from the first line we can write the b1 vector as 2 I cap minus j cap plus k cap. So from the second line we can write the b2 vector as 3 I cap minus 5 j cap plus 2 k cap. Now let's find the a2 vector minus a1 vector. Now 2 I cap minus 1 I cap, that is I cap. Next j cap minus j cap, that is 0 j cap. Next minus k cap minus 0 k cap is minus k cap. So after finding a2 vector minus a1 vector, let us find b1 vector cross b2 vector. That is the Cartesian product between these two vectors, b1 vector and b2 vector. The first row we have to write I cap, j cap, k cap, and the second row we have to write the components of b1 vector, and third row we have to write the components of b2 vector, that is scalar components of b1 vector and b2 vector, that we should have to write in the second and third rows of the determinant. Now let's find the value of this determinant. So by using the first row, I cap into, delete the column and row where I cap is standing. So minus 1, 1, minus 5, 2. Minus 1 into 2 is minus 2, and then minus 5 into minus 1 is plus 5. And then minus j cap into 2 into 2 is 4, and then minus 3 into 1 is minus 3. And then k cap into 2 into minus 5 is minus 10, and then 3 into minus 1 is minus 3. Extra minus will come, so plus 3. So I cap into minus 2 plus 5 is 3, so 3 I cap. Next 4 minus 3 is 1, 1 into minus j is minus j cap, and then minus 10 plus 3 is minus 7 into k cap is minus 7 k cap. Next a2 vector minus a1 vector dot b1 vector cross b2 vector. Now let's find the scalar product between these two vectors, a2 vector minus a1 vector dot b1 vector cross b2 vector. It's merely a scalar product. Now let's write the value of a2 vector minus a1 vector, that is I cap plus 0 j cap minus k cap dot b1 vector cross b2 vector. Already we calculated as 3 I cap minus j cap minus 7 k cap. Now let's take the dot product between these two vectors. So I cap and I cap we have to multiply. So 1 into 3, 3. Next 0 into minus 1, that is 0. Next minus 1 into minus 7, that is plus 7. So 3 plus 7 is 10. So a2 vector minus a1 vector dot b1 vector plus b2 vector is 10. Next let's find the magnitude of b1 vector plus b2 vector. Already we calculated b1 vector plus b2 vector. Now let's find the magnitude, that is square root of 3 square plus 1 square plus 7 square, that is 9 plus 1 plus 49. 49 plus 1 is 50, and then plus 9, 59. Square root of 59 is the magnitude of b1 vector cross b2 vector. Distance between two skew lines is a2 vector minus a1 vector dot b1 vector cross b2 vector the whole divided by magnitude of b1 vector cross b2 vector whole modulus. Why we are writing the whole modulus? Because the distance is always positive. Next, we already calculated the numerator value as 10, so we are substituting numerator by 10, and then denominator value already we calculated square root of 59. So 10 divided by square root of 59 is the distance between given two skew lines, and the unit is simply units only. Find the distance between the lines L1 and L2 given by L1 is r vector, which is equal to I cap plus 2j cap minus 4k cap plus lambda into 2i cap plus 3j cap plus 6k cap. Line 2 is r vector, which is equal to 3i cap plus 3j cap minus 5k cap plus mu into 4i cap plus 6j cap plus 12k cap. Now let's find the solution. Here, from the given two lines, we can find a1 vector, a2 vector, b1 vector and b2 vector. What is a1 vector? So, from the given first line, we can write the a1 vector. That is, what is a1 vector? I cap plus 2j cap minus 4k cap. Similarly, from the given second line, we can write the a2 vector as a2 vector is 3i cap plus 3j cap minus 5k cap. So from the given two lines, we observe that given two lines are parallel lines. So 2, 3, 6 and 4, 6, 12 are proportional values. So B vector we can take as 2i cap plus 3j cap plus 6k cap. Next, let us find the a2 vector minus a1 vector. So the a2 vector minus a1 vector is 3i minus 1i, that is 2i. Next 3j minus 2j, that is 1j. Next minus 5k minus of minus 4k. So minus 5k plus 4k is minus k vector. Next, let us find the b vector cross a2 vector minus a1 vector. Actually, it is a cross product between two vectors. So we used to write the formula determinant of the first row is filled by I cap, j cap, k cap. Next, the second row is taken from the b vector 2, 3, 6, the coefficients 2, 3, 6. The third row is taken from a2 vector minus a1 vector 2, 1, minus 1. So the determinant of ijk 2, 3, 6, 2, 1, minus 1 will be the value of b vector cross a2 vector minus a1 vector. Now let us find this value by expanding the first row. Now I cap into, delete the rows and columns where I stands. So 3, 6, 1, minus 1. So its value is 3 into minus 1 is minus 3, 1 into minus 6 is minus 6. Next, minus j into 2 into minus 1, minus 2, 2 into minus 6 is minus 12. Next, plus k into 2 into 1 is 2, minus 2 into 3 is 6. Next, minus 3 minus 6 is minus 9 into I cap, minus 2 into minus 12, minus 14 into minus plus 14 j cap. Next, 2 minus 6 is minus 4 k cap. Magnitude of b vector is square root of 2 square. What is 2 square? That is 4. Next, 3 square. What is 3 square? 9. Next, 6 square. What is 6 square? 36. So square root of 4 plus 9 plus 36, that is 49. Square root of 49 is 7. Next, magnitude of b vector cross a2 vector minus a1 vector, which is equal square root of minus 9 the whole square, that is 81, plus 14 square is 196, plus minus 4 the whole square is plus 16. Now square root of 81 plus 196 plus 16. Now let us add these three values, 196 plus 16 plus 81, that is 293. So square root of 293 is the value of b vector cross a2 vector minus a1 vector. That is, the magnitude of b vector cross a2 vector minus a1 vector is square root of 293. Now let's find the distance between two parallel lines. What are the parallel lines? Given two lines, line 1 and line 2. So what is the formula for the distance between two parallel lines? It is completely different from the skew lines. So the magnitude of b vector cross a2 vector minus a1 vector divided by magnitude of b vector, the whole magnitude. Why we are writing the whole magnitude? Because the distance is always positive. Now the numerator value is square root of 293 that we already calculated. Now denominator, what is the denominator value? That is 7. So square root of 293 divided by 7 units, because it's a distance, so we are writing units. Find the distance between the following lines: x minus 3 divided by 1, which is equal to y minus 5 divided by minus 2, which is equal to z minus 7 divided by 1, comma x plus 1 divided by 7, which is equal to y plus 1 divided by minus 6, comma, which is equal to z plus 1 divided by 1. From the numerator, we can write the x1, y1, z1, that is 3, 5, and then 7. From the second line, the numerator, we can write x2, y2, z2 as minus 1, minus 1, minus 1. From the denominators of the two line, we can write a1, b1, c1. That is a1 equal to 1, b1 equal to minus 2, c1 equal to 1. And then a2 equal to 7, b2 equal to minus 6, and then c2 which is equal to 1. So next, x2 minus x1, y2 minus y1, z2 minus z1. And then the second row is a1, b1, c1. Next, the third row, a2, b2, c2. The whole modulus, that is determinant value. So the determinant of these things, let us find, because it is the numerator of the distance formula. Let us calculate the numerator separately and denominator separately. So x2 minus x1, already we know the x2 value, that is minus 1. So minus 1 minus 3 is minus 4. Next, y2 minus y1, minus 1 minus 5, that is minus 6. And then z2 minus z1, minus 1 minus 7, minus 8. Next, 1 minus 2, 1. And then third row is 7 minus 6, 1. So these values we calculated and place in the respective positions. Now the determinant of this value, let us find. By expanding any one of the rows or columns, we can find the value of this determinant that we studied already in the chapter number 4. So now we are going to find the value of this determinant by using the first row. So minus 4 into its minor. What is the minor of minus 4? Minus 2, 1, minus 6, 1. So this small determinant is called the minor of minus 4. Next, minus of minus is plus. So plus 6 into the minor of 6. 1, 1, 7 and 1. And then minus 8 into the minor of minus 8. What is the minor of minus 8? 1, minus 2, 7, minus 6. So this is the minor of minus 8. Next, let us find the value of the determinant minus 2, 1, minus 6, 1. Just do the cross multiplication. So minus 4 into minus 2 into 1, that is minus 2, and then in the off diagonal direction 1 minus extra will come. Minus 6 into 1 is minus 6, so into minus is plus 6. Next, plus 6 into 1 into 1, that is 1, and then 7 into minus 1 is minus 7. And then minus 8 into 1 into minus 6 is minus 6, and then 7 into minus 2, minus 14 into or minus extra, so plus 14. So minus 4 into minus 2 plus 6 is plus 4, and then plus 6 into 1 minus 7 is minus 6, and then minus 8 into minus 6 plus 14 is 8. Next, minus 4 into minus 4 is minus 16. 6 into minus 6 is minus 36. Minus 8 into plus 8 is minus 64. Now, just add minus 16, minus 36 and minus 64. Now, the value is, so minus 16, minus 36, minus 64 is minus 116. After finding this value, let us find the distance between given two parallel lines. But we have to calculate the denominator value, and then after finding the denominator value, we can substitute in the formula so that we can reduce the difficulties. Now let us calculate the denominator of the formula, that is a1 b2 minus a2 b1 the whole square plus b1 c2 minus b2 c1 the whole square, and then plus c1 a2 minus c2 a1 the whole square, and then whole square root. These value let us calculate. Already we know the values of a1 b1 c1 a2 b2 c2 values. All these values let us substitute in this formula. So after substituting and after simplification, we got the value 116. Now let us calculate the distance between given two parallel lines by using the formula. The formula is x2 minus x1, y2 minus y1, z2 minus z1. Next, the second row is a1, b1, c1, and the third row is a2, b2, c2, and then the whole determinant. And then
divided by square root of a1 b2 minus a2 b1 the whole square plus b1 c2 minus b2 c1 the whole square plus c1 a2 minus c2 a1 the whole square. Next, let us substitute the numerator value, that is minus 116 divided by the denominator value, also we calculated as plus 116. So now square root of plus 116. Next, the whole modulus we have to put because the distance is always positive. So the minus will become plus if we take the modulus. After that, the 116 we can write as square root of 116 into square root of 116. Now 1 square root of 116 will get cancelled. So the answer is square root of 116 units.